In this Level 2 course, you'll be introduced to the LubeFiltration system. You'll learn about efficiency and the established test standards. You'll also be familiar with contamination and the servicing practices for lube filters. Let's begin with a review of the material learned in the Level 1 Fleet School LubeFiltration module. First, we learned that the importance of lube filtration is to remove unwanted contaminants from the oil in order to protect the engine components and increase system life. We also learned the two types of particulate contaminants in lube systems: organic or sludge and inorganic dust. We learned that the measures of performance for lube filters are efficiency, capacity, and cold flow ability. We learned about several lube filtration techniques, including full flow, bypass, and combination filtration. Finally, we were introduced to the FleetGuard product solutions for lube filtration: Stratopore Media, the Venturi Combo Filter, and the Stacked Disc Bypass Filter. When you have completed this Level 2 course, you will understand the difference between full flow and bypass filtration. You will be aware of the effect of contaminant in the lube system, and finally, you will be introduced to the Venturi Combo Filter design. So why use both full flow and bypass filtration? Filters to engines and lube oil are like kidneys to animals and blood. Kidneys filter blood in animals, and if they're not doing a good job, death or life termination is the outcome. Filters remove impurities and wear, causing contaminant from the engine's lifeblood, oil. If the filters are not doing a good job, engine life can also be cut short. Let's look at a basic lube oil filtration circuit. Oil pickup screen. Oil is drawn up by the pump through the pickup screen. The screen is a rather open mesh and, other than stopping rocks and rabbits, it does little in providing filtration as we know it. Oil pump. The oil pump is a fixed displacement gear type, and its pumping flow rate is directly determined by the various RPMs of the engine. A high-pressure relief valve and/or pressure regulating valve downstream from the pump opens when predetermined pressure is experienced and dumps excess oil from the pump back directly to the sump. Bypass valve. Oil flows through the full flow filter to the engine's moving parts, passing between the tolerances as a metal-to-metal barrier film and exiting to shower back down into the sump. Should restriction to the necessary flow to maintain system pressure at the filter occur, all full flow filters have a bypass valve either in the mounting head or incorporated within the filter. This situation can occur sometimes at cold startup when the oil is cold and more viscous, or when the filter begins to plug with contaminants. The valve will crack open when the difference in pressure going in and out of the filter is just beyond the pressure setting of the valve. Oil starvation to the engine is then avoided by allowing some oil to bypass the filter to make up pressure going directly, unfiltered, to the engine's moving parts. Allowing unfiltered oil into the engine is not ideal. However, it is better to have dirty oil than no oil at all. Bypass filter. A bypass filter allows for finer filtration and takes over the fine filtration not achievable by the full flow filter. To be able to get finer filtration from the one full flow filter would be ideal with this earlier circuit design. However, the filter would need to be increased substantially in size. In later engines, this one filter concept was accomplished with the introduction of combo and later Venturi combo filters. With the bypass filter bleeding off some of the full flow oil, around 10% of the full flow, much finer filtration is possible, as high oil flow rate is not a priority and oil goes directly back to the sump. Also, this system alleviates concerns about the engine's moving parts should the flow through the filter become too restricted. Note there is no bypass valve fitted to bypass filters because of this fact. Full flow and bypass filters working together achieve finer filtration. In this diagram, we see a 40-micron absolute full flow filter. Note, it is 100% efficient at stopping 40-micron, 50-micron, and all larger sizes. However, it doesn't perform as well at 30 microns, where its efficiency drops to 99%. And as the sizes get smaller, the efficiency drops even further. Now look at the bypass filter. It takes over and accounts for efficient removal of the finer particles smaller than 40 microns. The bypass filter pictured at the bottom right is the first filter designed for this purpose, the LF750. It's a depth-type filter, meaning it doesn't rely on media surface area to get the holding capacity, as is the case with a pleated element design. It relies on capture taking place during the extended distance traveled by the oil through the heavily packed media. Real-world contamination consists of 75% to 90% organic material, or sludge. Fleetguard has conducted extensive field tests that prove that less than 20% of the total matter trapped by a lube filter is inorganic, dirt, and the remainder is organic sludge material. What is really killing the engine? Determining the worth of one filter brand compared to another as far as engine filters goes is commonly expressed using test dust and laboratory procedure, dust capacity, and efficiency. A few years ago, Fleetguard, in conjunction with Cummins, realigned their thoughts on how dust impacts engine wear and redefined what was really happening within the diesel engine as far as wear is related to dust test results. The main bulk, 75 to 90% of contamination in lube oil, is organic sludge material generated by engine operation. Sludge is the main material found in oil that plugs filters and causes the bypass valve to open, sending abrasive, unfiltered oil to the engine's moving parts. In conclusion, API, EMA, and ASTM now acknowledge Cummins engine high soot test as mandatory criteria to be met for ESI oils such as CI4 and CI4+. What is sludge? Sludge is a byproduct of combustion, much of which exits the engine via the exhaust system, and some of which makes its way past the piston rings to the sump. Left unchecked, oil drains extended too far, and agglomeration begins. Fine, mostly submicron carbon particles, as well as other binder-type byproducts, varnishes, and lacquers, come together and form filter plugging sludge. Agglomeration is exponential, meaning when it begins, it is rapid and not gradual. So, what are the effects of sludge in the lube oil? Carbon particles, being mostly submicron or less than 1 micron in size, while well dispersed within the oil, will generally pass through moving part tolerances, causing little effect, unless, of course, their numbers build up or agglomeration occurs. If the oil appears black, it is presenting the carbon byproducts as dispersed and in solution throughout the oil. However, it doesn't mean that the oil is still serviceable. Minutes after a run, a simple dipstick view of the oil may give a new oil-like appearance. What is happening is the additives in the oil holding and dispersing the material, sludge, have been exhausted, and the material, sludge, has dropped to the bottom of the sump pan and plugged the filters. All that is left is base oil. Today's oil additive packages, consisting of friction improvers, viscosity modifiers, detergents, and dispersants, are up to, and in some brands, over a 2-digit percentage volume of the oil. If these additives are exhausted, engine life will quickly drop to zero. Fleetguard's unique stacked disc bypass media has been used for many years, beginning with the LF777 spin-on bypass filter, as first fit on Cummins engines in the late 70s. Because of its unique multi-directional flow design with many capture chambers for high efficiency and capacity within the stack, it is still used today in combo filters such as LF3000 and combo Venturi filters such as the LF9000. Capturing the vast majority of material in the bypass section helps keep the full flow section from plugging and causing the bypass valve to open and allow unfiltered oil to travel to the engine's moving parts. The benefits of using a combination of full flow and bypass filtration is clear when considering the reduction in wear that can be achieved. Additional wear can reduce the efficiency of the engine and lead to unnecessary engine rebuilds. So let's look at what stacked disc bypass filtration achieves. Looking at the graph below, you can see what adding a stacked disc bypass filter can do for your engine. The SAE reported testing that shows dramatic reduction in piston connecting rod bearing wear when using bypass stacked disc filtration in conjunction with full flow filtration compared with just full flow filtration. In the chart, wear was tested in 4 areas in the engine: the upper connecting rod bearing, the lower connecting rod bearing, the upper main bearing shell, and the lower main bearing shell. The blue bars represent 100% wear using a full flow filter only. By adding a bypass filter, wear was reduced from 30% to 64% for SAE 710813 and 790089. That's a substantial savings in total cost of ownership. Compare the outlets. The conventional LF3000 type filter has 2 distinct oil flows, as previously discussed. In the Venturi version, such as LF9009 and LF9000, full flow oil passes through the stratopore media around the bypass tube into the throat of the Venturi. What are the advantages of using a Venturi filter? First, the Venturi is suitable for extended service. It has improved seal material to safeguard against cracking and/or thermal set. It also has a thicker shell and nut plate, which safeguards against extended pressure pulses. Stratopore media is included for durability against prolonged heat and oil flow. The Venturi is the only filter of its type and application approved by Cummins CECO SAM 10765, meeting the requirements of Cummins High Soot Test. What are the benefits of the Venturi combo filter? The Venturi is still the best combo filter in the industry. First, as you've already learned, this filter is both a full flow and bypass filter in one. It has a single inlet and a single outlet. The full flow element is high performance stratopore media, and the bypass media is a stacked disc design. No retro kit is required, and it is first fit with OEM. Finally, it is built tough for ESI. Sludge removal and fine filtration impact. The graph shows the contrast between stacked disc bypass and the large amount of sludge material captured compared with a full flow filter in a single pass laboratory test. The Venturi combo filter is capable of capturing at least 3 times more contaminants than conventional full flow only filters. It is capable of removing 5 times more dust than is needed in real-world applications. Full flow only filters, at best, remove greater than 20 plus micron particles and only improve on this as the filter begins to plug. Sludge is the contaminant that plugs filters, so if plugging occurs, it is better to have it occur in the bypass section, not the full flow section. The stacked disc bypass filter section also carries out the function of effectively removing those particles recognized as causing the most wear within the engine, particles smaller than 20 microns. Real-world testing, Venturi versus the competition. Using an ASTM-approved Cummins engine test approved for next-generation ESI oils under controlled conditions, an M11 400 engine was run for a total of 300 test hours over varying hourly intervals. The fuel injection timing is retarded and the engine is overfueled to generate excessive soot. Results: the Venturi filter oil cleaning capability is superior to the other brands that offer a matching filter. By contrast, the Donaldson No Bypass Mono Synthetic removes only 1/3 of the contaminant compared to the Venturi combo filter with built-in bypass and full flow filtration. The Donaldson No Bypass Mono Synthetic can only last 1/4 of the distance before plugging, compared to that of the OEM FleetGuard Venturi combo filter with built-in bypass and full flow filtration. In conclusion, the Venturi combo filter demonstrates extended service intervals without compromising engine protection and can easily be fitted to many engines that currently have only full flow filtration. Now that you've completed the Level 2 Fleet School Lube Filtration module, you should know the differences between full flow and bypass filtration. Namely, that full flow filtration filters the full flow of lube oil, protecting the engine from coarse particles. Bypass filtration filters 1/10 of the flow, removing fine particles. You should also know the effects of contaminants in the lube system. You should also understand that controlling abrasive contaminants of 20 micron or smaller controls engine wear, and that removing sludge-forming materials reduces engine wear and operating costs. Finally, you should be familiar with the Venturi combo design, which combines the benefits of full flow and bypass filtration in one filter with greater efficiency and capacity.